So what we recognize is that we must build knowledge slowly and gradually through experience and schooling, and build these knowledge structures in long-term memory. Now this is an example of a concept map drawn from an interview with a child in grade 2. The reason we invented concept maps was to find a way to represent children's knowledge in early grades and to see how that knowledge structure changes over time. So here we see in this map that this child has some knowledge about water and ice and knows that they're made of the same things, but there's also some knowledge that's not well connected and some ideas that are missing. But this student chose to try to understand everything that he was learning, and by grade 12 he has built a very complex and very accurate knowledge structure of the nature of matter and energy and molecules and how substances can change from solid to liquid to gas and why they undergo these changes. Here's a concept map by another student who was a rote learner, and this student, also a student in grade 12, had studied science throughout elementary, junior high school, and high school. But her knowledge structure is not nearly as complex as the structure we saw for Paul, and it contains many misconceptions, many invalid ideas. When a person is building knowledge by rote, first of all, very little knowledge structure is developed, but secondly, it's full of errors. So we see, for example, that she thinks that when air expands, it does so because molecules get fatter. And she also thinks that when molecules get fatter, they get lighter, and that's why air rises. Of course, molecules don't change their size, but the space between molecules changes as we heat matter up. Now here's a college biology student at the beginning of the semester. And this is what she learned in high school and brought to her college class. She was a very good high school student, and she knows that there are eukaryotic cells and prokaryotic cells, two different kinds of cells, but she has these backwards. Her understanding is faulty, and even her labels are faulty. This is what happens when students memorize. They often remember things, but they don't get them straight. They don't get them correct. Also, she doesn't know how to connect organs to cells and to tissues and other things that she should have brought with her from high school. Now, she built concept maps from the beginning of the course right through the end of the course, and this is what her knowledge of cells looks like at the end of the semester of study of biology. And look how complex her knowledge structure is. By doing concept maps regularly through the semester, she has built this powerful knowledge structure. Here's a concept map that explains why we have seasons. At Harvard University, they interviewed graduates and alumni and asked, why do we have seasons? And 21 out of 23 of the graduate students could not explain properly why we had seasons. Even a student who had taken a course in physics of planetary motion. What these students failed to understand is the idea that the Earth is tilted on its axis, and as it goes around the sun during the year, it is first pointing toward the sun in the north and then pointing away from the sun. And that's why we have seasons, at least in the northern part of the world and the southern part of the world. In Colombia, of course, your seasons are more dependent on when the rains come than the temperature changes. Now, what we are planning to do is to provide expert maps such as you see here in orange, showing fundamental ideas of science. And then we're going to ask students to use these maps as a scaffold or as a framework to build their knowledge. Because if they were only to memorize these maps, that would be the worst form of rote learning. But if they take the map and start building their own knowledge, adding their own knowledge to this map, such as you see here with the concepts added in blue, then they would be learning meaningfully. With concept mapping software we have developed, you can also go out on the internet. You could use the concept map to search the internet. And you will find websites that give you information, such as on cloud patterns we see on the left side here. And one of the things that causes variation in temperature is the amount of cloud cover. Another thing that we could get from the internet is information on the amount of solar radiation or the heat from the sun as we go from morning to noontime and back into night. Many kinds of data and ideas and pictures and videos and any sort of information that could be digitized and put on the internet can be brought into the concept map as a resource. The concept mapping software allows you to attach icons, as you see under seasons at the top. And when you click on this icon, you get one of these resources. Many, many resources could be attached to a single concept map, and it becomes really a portfolio of what that child has learned. Here's an example of a map dealing with the United States government and how it is organized. Now, a student could begin to use this map and start adding to it information on senators and what senators are from what state, and on, building an elaborate map of government and coming to understand government in a way that few students currently do. Here's a map dealing with plants. It's very simple, but a student can begin to add resources to this map using the icons down below that signal that a resource has been added or several resources have been added. And now we see that by clicking on these icons you can get pictures of flowers, such as the violet, which is the national flower of Costa Rica. Shown up in the upper left side is the image from a videotape that shows a flower opening up. So videos can be placed as resources attached to concept maps. And there are no limit to resources that a child could add to the concept map and build a knowledge structure that is now represented in this form of a concept map. This is a concept map on planet Mars that serves as an index to many, many maps on planet Mars and many pictures and videos of planet Mars. And all of these can be downloaded through the internet from a website managed by NASA in California. Well, these are some of the ideas that underlie concept maps and some of the things that can be used when you want to help students learn how to learn meaningfully and to build knowledge structures. Here are some references that you may want to look at. They are available both in English and Spanish, as well as in several other languages. And you can get concept mapping software from the Institute for Human and Machine Cognition at the address shown below. And of course you could write to me at the address shown below as well. Thank you very much, and good luck to you in your efforts to learn meaningfully.